You know, you do it without even thinking about it. Every single day you hop in the car, you just instinctively leave a bit of a gap between your bumper and the one ahead. It's just common sense, right? A little wiggle room, just in case.
But what if that simple little buffer isn't just about avoiding a fender bender? What if that same exact principle is what's keeping our bridges standing, what's keeping spacecraft flying, and maybe, just maybe, what's keeping our entire society from falling apart? So today, we're going to pull back the curtain on this idea that is literally everywhere, but most of the time, completely invisible. This is our explainer on the margin of safety.
All right, so first things first, what in the world are we talking about when we say margin of safety? Let's lock in a definition.
You know, when you boil it all down, it's really just a buffer. It's the space between a system's absolute maximum capacity and the normal everyday load it actually faces. Think of it like the extra strength in a rope, or the extra cash in your savings account, or the extra half hour you build into your schedule. It's the capacity you hope you never have to use, until you desperately do. And it turns out there are really only 3 ways to build this buffer. 1, you can just build a stronger bridge. That's increasing capacity. 2, you could limit how many trucks can go over it. That's decreasing demand. Or, and this is the really clever one, you can design a system that can actually flex and adapt when things get stressful. And we're going to see just how important that third one is.
Okay, so let's take this out of the abstract and see where the rubber meets the road. We'll start in a field where getting this wrong isn't just bad, it's catastrophic. Engineering. So here is the absolute key insight. Professionals know that averages are liars. A system never ever fails on an average day. It fails on the worst possible day. So you don't build a bridge to handle a typical Tuesday morning commute, you build it to handle a once-in-a-century storm that happens to hit during rush hour. And they actually quantify this? They call it a safety factor. Just look at this chart. A bridge with a safety factor of 2.0 is built to handle twice its maximum expected load. For a crewed spacecraft where there is absolutely zero room for air, that margin gets even bigger, maybe 4 times what's expected. It makes sense, right? The bigger the consequences of failure, the bigger that margin has to be.
And this is where it gets really mind-bending. There's this incredible insight from NASA that says the margin is largest where understanding is weakest. Think about that. They're not just adding a buffer for the risks they know about. They add the biggest buffers for the things they don't even know they don't know, the unknown unknowns. The margin of safety isn't just a shield against bad luck. It's a profound admission of humility. It's a hedge against our own ignorance.
But see, building a margin isn't just some straightforward math problem. Because the second you add people into the mix, well, things get weird. This is the human factor.
I mean, it seems like a no-brainer, doesn't it? If you want to be safer, just add more safety features. Make the margin bigger. Everything gets safer. Simple. But, is that really true? Okay, check this out. Take the seatbelt. It was obviously designed to make drivers safer. But a really funny thing happened after they became common. People, feeling safer, started to drive just a little bit faster, maybe follow a little bit closer. It's a phenomenon called risk compensation. It's like we all have this internal risk thermostat. And when a new safety feature gets added, we adjust our behavior to keep our feeling of risk at about the same level. We basically spend the new safety margin on performance.
It's kind of like this. You can set your watch 15 minutes fast to try and give yourself a time buffer for getting places. But if you always know it's fast and you're always mentally subtracting those 15 minutes, well, you haven't actually created a margin, have you? You're still going to be late. You've just gamed your own system. A margin only works if we respect it.
All right, so if we know that margins can be eaten up by our own behavior, how do we actually make them work for us? In our lives, in our work. Let's bring this home.
So, a margin is pretty much useless if you don't even know it's being used up. And this brings us to a critical difference: ductile versus brittle failure. A ductile system, like a metal beam, it bends and groans and deforms before it finally snaps. It gives you warning signs. But a brittle system, like a pane of glass, looks perfectly fine right up until the moment it shatters into a million pieces. So this is the question you have to ask yourself. Is my margin ductile or brittle? In your finances, in your big projects, in your team's energy levels, do you get clear warning signs that the buffer is shrinking? Or does it just look fine one day and then completely collapse the next? Because a brittle margin is barely a margin at all. It's an illusion of safety.
So here's a little toolkit you can use. 3 questions. First,
Is this system designed for the average day or is it built for the extreme day? Second, does this system give me clear, ductile warning signs before it breaks? And third, and this one is huge, who gets the benefit from using up the margin and who pays the price when it's all gone? Because if those aren't the same people, you can bet that margin is in serious danger.
And this brings us right back to where we started, that simple gap between cars. The only reason we can drive without constantly doing physics calculations in our head is because we've all agreed to build in a margin. This quote just nails it. Civilization advances by extending the number of important operations which we can perform without thinking about them. Margin of safety is what makes progress possible. It's a silent, invisible buffer that lets us build complicated things, trust the bridge we're driving over, and focus on moving forward because we've planned for the day things go wrong. It is the space between order and chaos.